There's been a lot of debate in the Telemark community about the best way to mount your bindings to your skis. Typically, we use the option on the left here. That's a standard binding screw. This one happens to be from 22 Designs. It's a wood screw that's designed to just be attached into the ski with traditional wood glue. And with the popularity of the 6-hole mount, that seems to work pretty well for most people. However, some of us are looking for a little bit more durability out of a mount, and usually what's recommended is the option on the right. On the right here we have a threaded insert. This is from Binding Freedom. If you're not familiar with these, basically you drill a larger diameter hole in the ski. You tap that hole with a tap. You're creating threads in the wood. Then you thread this insert into those threads with epoxy. And the machine screw that's down below, it's actually 2 pieces. The machine screw then threads into the threaded insert. The purpose of these is so that you can move your bindings from ski to ski indefinitely. So if you have a large quiver or you have some skis that don't get skied very often and you just want them to have inserts so you can move some bindings over, those are a great option. The side benefit is that people claim that it's a stronger mount. I think that's because it has a larger diameter and higher thread count, and the mounts always use epoxy instead of wood glue. So we're going to test that today, whether that mount is actually stronger or not. And so I have some test skis set up here. I have 3 skis representing 3 different layups. The first ski here is a Hypervector from Volet, and these skis are junk, so don't think I'm just ruining a good ski. You can see this crack here. These were broken by an alpine skier. These skis are very fragile and not recommended for Telemark. So this will be very interesting. So for people who are looking for a stronger mount on their Hypervector skis, we're going to have a good test here. Now I've got inserts and screws. So traditional screw and glue, and this is insert and epoxy. And I've kind of spread them out the best I can and kept them within the mounting area of the Hypervector. I also have these vintage K2 Apaches, which are just a wood and fiberglass layup. And these are awesome because this whole section here in the middle is all the same layup. It doesn't have a designated mounting area. It's all consistent wood. So it allowed me to put a lot of screws in. So we're going to get a lot of reps. So hopefully reduce our variability with a bigger sample size. And then up here we have the Legend Pro Rider. This is going to be representing our metal layup skis. So we have some epoxied in inserts over here and some glued in screws up top. To test the force it takes to pull these out, I made up this little rig. So what we have here is a claw hammer head welded to a socket. That's just so that I can attach it to this torque wrench. And so the method, I'm just using one hand here, so bear with me. The method is going to be basically as you see it. So I'm going to put the claw around the screw head. I have a little Sharpie mark on the claw because I realized in some testing that you get inconsistent results if you have the screw at a different location in the slot. So everyone is going to be lined up to the center of that Sharpie mark. I'm going to set the torque of the torque wrench to say 40 Newton meters or 40 foot-pounds. And then I'm going to crank on it. If the screw pulls out, then I'll know that it took at least that torque. However, I'm gonna start low and work my way up. So if I start at 20, it doesn't pull out, move up to 25, click it again until I eventually get the tear out, and then I'll write the number down next to each screw hole. So that's the setup. I'm gonna go ahead and pull one out here. I'm not gonna really be able to film it just because it's kind of a two-handed operation and finicky to get lined up. But I'll show you after I do my first one here. All right, I lied. I tried to figure out a way to film it. So here we go. This is 40 foot-pounds. You'll notice it didn't pull out, so I'm going to go ahead and increase to 45. And I know from a test ski that 40 foot-pounds is a pretty safe place to start. Again, make sure I'm on that Sharpie line. Try again. 45. Let's go up to 50. Now these measurements aren't going to be the actual force that it takes to remove the screw. There are some confounding variables with the leverage that happens from the hammerhead. However, it will be a good way to get a comparison between the two mount types. If I wanted to know exactly the PSI it took to remove these screws, I would need some pretty expensive equipment, not some stuff I can just bung together from Harbor Freight. All right, but going 50 foot-pounds. All right, just reset here. Oh, had a lot of cracking on that one. I'm just going to go up to 52 and a half. Oh, nothing. 55. This is the screw and glue, by the way. So this first one I'm doing is just screw and glue. 55, still good. We'll go 57 and a half. A lot of cracking, but it's still in there. We're up to 60 foot-pounds. 60, not doing it. Let's go right up to 62 and a half. Oh my goodness. 65. Oh. All right, so first one down on the K2 here. That was a screw and glue. And the last number it held in at was 62 and a half. So that's what I'm going to write next to the number here. We'll go 62.5. It pulled out at 65. So I'm going to go ahead and go down the line. I'll do one insert on camera, but then I'm just going to go down and do this whole ski all at once because it's kind of a tedious process. All right, so this is our first insert on the K2. I'm just going to go ahead and start right at 55 since I had to work up pretty close on the other one. So here we go, 55. Oh. Okay, 55 held. Let's take a look at what happened here. So quite a lot of cracking on the top sheet. Interesting. I'm going to go ahead and pull this one out to failure and see what we get for a result here. But I'm just going to go up 2.5 because that was pretty, felt pretty close right there. All right, 52.5. Or 57.5. And there it's out. So yeah, that was the epoxied insert. It held in at 55, but it failed at 57.5. So I'll go ahead and write 55 next to it. Yeah, and work my way down the line here and see what the results are. That's a little surprising. I thought it would be stronger. But yeah, here we go. All right, so I've worked my way down the ski here, and I've gotten 6 of each type pulled out. You may notice there's still some regular screw and glue screws remaining. That's because these were I screwed in too far, and I couldn't get the hammer claw underneath far enough to reach the Sharpie line. So these wouldn't have been a valid result, so I left them in. Luckily, I had screwed in a few extras. But yeah, here's the results of the first setup. So for the K2, the average for the screw and glue was 62.91, and the average for the inserts was 56.25. Kind of surprising, yeah, the inserts didn't do as well. In case you're wondering, the glue that I used was just Gorilla Wood Glue Ultimate, which is a waterproof wood glue, which is what you need to use to mount skis. And the epoxy I used, I don't have any here now, but it's the 8-hour epoxy that you buy at Ace Hardware. It's not the 5-minute. It's not the good stuff. This is what I would recommend using is G-Flex epoxy. This is like a 24-hour or even longer epoxy, but this stuff is flexible, really good for skis. I didn't have any of that at the time, so I just used the best stuff that you can buy at the hardware store for skis, which is what I think most people will probably be using if they're doing a home DIY mount. But yeah, kind of interesting. We'll talk more about the results later, but let's go on to the Hypervector. So I got the Hypervector all done here. Kind of interesting results. You might notice I got some numbers in parentheses here. Basically what's happening is the ski is failing before the insert or screw pulls out. So this number over here is when the ski core has failed, and I'll show you what I mean by that in just a sec. And this number over here is when the insert actually comes out, or the screw. So the first screw came out at 45. It also failed at 45. So yeah, as you can see, the insert 70 and 75 foot-pounds for the insert to actually come out. But let me show you what's happening here. So this is an insert, threaded insert. I'm just got my regular hammer here. Now, I don't know if I can line this up right for you guys to see, but what's happening, can you see the whole top sheet pulling up? This insert is only holding on to the top sheet. Now you got to give Volet some credit here. This top sheet is really, really strong. And the greater surface area of the inserts gave them a big advantage of staying into the top sheet. But there's no real structural integrity left in that insert. All that integrity was gone at that 45 number, which was the same. I noticed the same phenomenon happening with the screws as well. So it seems like about 45 to 50 foot-pounds for both. Completely compromised the core, and then it took an additional about 20 or 25 foot-pounds to get the inserts to pull out of the top sheet. But I feel like at that point your ski is already ruined. This one, this person didn't have a binding tear out at all, but they broke. If I push down on the ski here, you can see that crack open up. They broke their ski just skiing it. These things are really fragile, really lightweight, but I think the not recommended for Telemark is a valid claim. So yeah, that's the results on the Hypervector. Kind of a non-result, but we'll go over it more at the end. On to the Legend Pro, the final ski, metal top sheet. Here we go. That's 65 foot-pounds on the Legend Pro. The screw isn't budging at all. We're on those volets at 65 foot-pounds. The screw is moving up and down, probably 3 or 4 millimeters. Sorry, don't have the best setup here. So yeah, already way more solid on the Legend Pro. Just finishing up the Legend Pro here. Sorry I'm not filming more of the tear-outs, but I don't have a tripod or any way to set it up, and it's a lot of force. This seems like a very calm video, but I am sweating down here pulling these screws out. So yeah, it's kind of a lot of work. We've got the Legend Pro finished up here. Similar results to the Volet. So the screws 70, 80, 77.5, and 67.5. Inserts 195. However, the core of the ski had about failed by 75 or so. So that's the same demo that I did on the Volet. Right down here, you can see, I don't know if you can see that, but without much force, the insert is moving up and down and pulling the whole top sheet with it. The only thing holding that insert in is the metal top sheet, which again is taking about 95 to 100 foot-pounds to pull out. But the core of the ski is completely compromised, right around 75 foot-pounds on this one. Those other ones were similar, which is about the same force it took to pull the screws out. The screws failed at the same time as the core. I don't know if that's an advantage. If your ski is damaged in this way, where the screw isn't holding into the core at all, it's only a matter of time before it breaks. So even though the insert is keeping the screw in better, it's kind of past the point where the ski is in good condition anyway. So yeah, I'm going to tally up the numbers a little bit and then do an analysis for you and give you my theory on what's going on here. I just realized I had a good example in my garage of what happens when the core of a ski fails and the inserts are holding onto the top sheet. Now this is the Legend Pro 105 mounted with inserts. Similar layup to the Legend Pro 97s that we were testing. These were previously mounted with 22 Designs binding. I pulled the old bindings off. When I went to put these inserts in, there was quite a bit of rust in the holes. The previous mount didn't use any glue, so they weren't sealed, and so the core was compromised. But I mounted them up anyway. I figured, oh, if I drill the hole a little bigger for the insert, maybe I'll get into some good wood. But that didn't happen. After a few runs, the top sheet of the ski started to lift off of the core. And that's because those inserts are, super strong and they're stuck to the top sheet, but the integrity of the ski is totally gone. So that's what I'm talking about, where it doesn't really save us anything to have the insert stuck to the top sheet. It's going to destroy the ski anyway. So just wanted to bring that example out. So what's the conclusion of this experiment? Should you mount your skis with the traditional screws and glue, or should you spring for this threaded inserts for a more durable mount on your Telemark skis? For me, it's going to be screw and glue every time, and I think the results will support my opinion on that. The K2s, just a straight wood and fiberglass, simple layup. The screws are actually stronger than the inserts. Now there could be a couple reasons for that, but I think the main one is that inserts to me don't look like they're made for wood. They look like they're made to thread into metal. It's kind of a machine thread, so I try to focus there. Where a traditional binding screw looks like every other wood screw you've ever seen. There's bigger landings on the threads for more bite, and the narrower profile displaces less material, and I think is overall stronger. So yeah, that could be what's happening with the K2. We had a similar range of 50 to 70 for the screws, 47.5 to 70 for the inserts. I do think that the screws were a little more consistent. We have one in the 150, 170, and the rest were all in the 60s, where the inserts, we had a 40, 50, 55, 60s, and a 70. So kind of a more inconsistent result from the inserts, and I think part of that is also the installation. Now I installed these, and I will admit on these K2s when I was just winging inserts in there, I did my best. However, it wasn't my best. I've done a lot better jobs when you're mounting a ski for yourself to ski. I've got my quiver over here. These moments I could pull the bindings off and you'd see a professionally done insert job. I've mounted a dozen skis or so with inserts over the years. These white skis back here have inserts mounted. I've mounted my own insert skis, skied them, and the process is really tricky. It's difficult to keep the tap straight. There's very little room for error. It's a much more difficult mount to do, and there's a lot more steps. And so I think even with this experiment, outside of that, even having a ski shop do it, I think you're going to get less consistent results. And definitely if you do it yourself and haven't done it a lot of times, your first few times you're gonna mess up. You're gonna have crooked inserts. You're gonna strip out the wood threads, especially on a lighter weight ski like these volets, and you're gonna be setting yourself up for failure. The wood glue and screw method has a lot more consistency, and it's way easier to do. Very forgiving. If your drill bit wanders and it's on an angle, you can kind of wind those things in sideways and they'll be just as strong. So I think that's what we were noticing with the K2. With the Hypervector and the Legend Pro, kind of a similar result where the core of the ski failed before the fastener pulled out completely. Specifically with the volet, I think what I've learned today is that I won't be mounting these with my Telemark bindings. They might be strong enough, and I'm generally not one who pulls bindings out of skis, but they were by far the weakest skis, weakest feeling as I was pulling on them with the hammer claw. Having that top sheet, having the core of the ski fail and the top sheet be the only thing holding in the insert, yeah, it's good that the insert, didn't come out until about 70, 75 foot-pounds, but the core of the ski failed, 50, 45, 45, about the same force where the screw pulled out. If you're riding around and you've got a compromised core and your inserts are just holding on to the top sheet of your ski, it's only a matter of time before that top sheet cracks or delams like this guy had, or until they pull out completely. So I would say Hypervector, the moral of the story is don't mount them with Telemark bindings. It's not recommended. It's not warranted. And if you are, I don't think it makes a difference, screws or inserts. By the time you do enough damage to pull an insert out, the core has long been compromised. And kind of the same situation with the Legend Pro, except way stronger. Metal laminate ski, both fastener types failed at about the same, the core of the ski failed at about the same force, but the insert stayed in longer. The difference with these skis is I think that force is high enough that you are not going to run into it in your normal usage, so might as well just use glues and screws. It's cheaper, easier to do. It's going to be plenty strong enough in this metal top sheet heavy duty ski. So yeah, no real reason to use inserts. And if you're going to swap bindings around, yeah, actually these skis have inserts in them for an Alpine binding. These are old inserts from Alpine binding, Solomon Morden. So someone was using these with inserts already to move bindings around. So that's the big advantage of inserts, I think, is if you're planning on moving bindings around, definitely they're a great tool for that. I think the tests I did today don't show any advantage in the mounting strength. But please let me know what you think. If there's a flaw to my methodology, which I'm sure there is, if you have an explanation for the results or any theories, personal experiences, please share them. I'm literally just some guy. This isn't the end all be all. There's probably a lot of science out there about screw thread depth and thread count and pitch that might tell a different story. But in my experience, I've skied dozens of skis with inserts and even more with glues and screw, and I've never had a problem with either. But in my mounting experience, it's so much easier to do the glues and screw and cheaper if you pay a shop to do it, that I would just go with that. So yeah, that's the conclusion of the video. Thanks for coming along on this journey, and have a great day.